Hello, my name is Ardi and we are going to solve recurrence relation with generating function. So here is the recurrence relation that we are going to solve. We are given that an is equal to 5an minus 1 minus 6an minus 2. And we are given initial condition a0 is 6 and a1 is 30. Okay, remember that an is actually a sequence. So an sequence, so it is just a0. We are given that a0 is 6, but I want to write it a0 first. a0, a1, and then a2, a3, a4, and so on until infinity, right? And remember, every sequence has a generating function, which is the polynomial form of this sequence. Okay, let's name the generating function of this sequence fx. So fx will be a0 x to the 0, which is 1. So I don't write it. And then a1 x to the 1, so a1x, and then plus a2 x squared, and then plus a3, which is multiplied by x to the third power, and so on. So I will have a4x to the fourth power, and it goes until infinity. So this is the generating function of an. Let's write that, generating function of an. So now our task is finding a0, a1, a2, a3, and so on that fulfill this recurrence relation. Okay. Okay, now let's leave the generating function for a while. Now let's see the given relation. So an is equal to 5an minus 1, and then minus 6an minus 2. Okay, we move all of this to the left hand side, so I'll have an minus 5an minus 1 plus 6an minus 2, and that will equal to 0. Okay, so now we want to get this into this form. So I want to multiply this by x to the n, because eventually this is plus an x to the n, right? And we have that here, so yeah, why not? Axn x to the n minus 5 a n minus 1 x to the n, and then plus 6 a n minus 2 x to the n, and that will equal to 0. Yeah, because 0 multiplied by x to the n is just 0. Okay, now because this is a sum of, this is the sum from 0 to infinity, so I will take the sum of 0 to infinity of this one. We'll have the sigma, and because we only care about a2 and so on, because we know a0 and a1, so I will have the n is equal to 2 until infinity. This is 2, why that looks like 1? Let's make it 2, and then we have an x to the n minus 5 an minus 1 x to the n, and then plus 6 an minus 2 x to the n, and that will equal to 0. Now I want to distribute the sigma to each term, so I will have sigma n is equal to 2 until infinity a n x to the n, and then minus 5, so I can take out the constant out of sigma, so I'll have n is equal to 2 until infinity a n minus 1 x to the n, and then plus 6 sigma n is equal to 2 until infinity a n minus 2 x to the n, and that will equal to 0. Okay, now let's name the sigma term. Maybe this one will be the first term. And then this one, we will have this as the second term. Yeah, this first term, second term, and then this one is the third term. Okay, let's see the first term here. First term. Okay, maybe I will use red. So the first term is sigma n is equal to 2 until infinity of this one, right? An to the x multiplied by x to the n. But this will be equal to a0. Oh no, it's not a0. a2 x squared, because we are starting from 2, then plus a3 x to the third, and then that will be a4x to the fourth power, and so on. But this is actually the generating function without this one, without a0 and a1x. So if we move this a0 and a1x to the left hand side, we get exactly what we want here. So here we will have this equal to fx minus a0 minus a1x. Fx minus a0 minus ax. So this is the first term. And now let's move on to the second term. Okay, the second term will be sigma n is equal to 2 until infinity a n minus 1 x to the n. So if we expand this, this will be a1 x squared plus a2 x to the third, and then plus a3 x to the fourth power, and then so on. So if we take out the x, okay, we can take out the x here and write the inside as a1x plus a2 x squared plus a3 x to the third power, and so on. We will have this function inside the bracket that will equal to this one. So if we move that I0 to the left hand side, we will get what we want. So we will have this is equal to x, and this is equal to fx minus a0. So this is for the second term. And for the last one, we will have the third term. Okay, let's rewrite the third term. We will have sigma from n is equal to 2 until infinity of a n minus 2 x to the n. Okay, and this will be equal to a0 x squared plus a1 x to the third power, and then plus a2 x to the fourth power, and so on. Okay, we can take out the common factor of x squared. So I have x squared, and then inside this I will have a0 plus a1x plus a2 x squared plus a3 x to the third power, and so on. But inside the brackets, this is exactly fx, right? Yeah, this is exactly fx. So I will have this third term is equal to x squared multiplied by fx. Okay, So now let's substitute back into the original equation. Substitute. Okay, let's have the original equation. Okay, how to do that? Okay, I think this is the lesson tools, right? Okay, quite good. Okay, nice. Yeah, I got it. Oh, it's not copied. Okay, let's copy it first. Okay. And here. Okay, now let's substitute back what we got from here. So the first term will be fx minus a0 minus a1x. Okay, so I will have fx minus a0 minus a1x. And then the second term, minus 5. What is it? X fx minus a0. So I have x and then fx minus a0. Okay, and then plus 6. The third term will be x squared fx. So I have x squared fx here. And all of this will equal to 0. Okay, now what can we do? We know a1 and a0, right? Because that is given in the problem. So a0 is 6 and a1 is 30. So let's substitute that into this one. So I will have fx minus 6 minus 30x, and then I will have minus, maybe I want to multiply this first, so I will have 5x, and then I will have fx minus a0. A0 is 6, right? And then plus 6x squared fx. That will equal to 0. Okay, now what can we do from here? Yeah, maybe let's do some simple algebra. Then fx and minus 6, I want to move that minus 6 to the right hand side, so I'll have 6 here. And then okay, I will have minus 30x, and I will have minus 5x fx, and then I will have plus 30x, and then for this one I will have 6x squared fx. Is nothing left? Yeah, nothing left. Okay, let's cancel this because this is minus 30x and this is plus 30x, so that will cancel each other. And now we have all term of fx to the left hand side, right? So I can factor out the fx. Let's factor out the fx, and then I can multiply it by, this one will be multiplied by 1, and this one will be multiplied by 5x, and this is multiplied by 6x squared. Okay, and that will equal to 6. Or we can get that fx is equal to 6 divided by 1 minus 5x plus 6x squared. Okay, now we can, this is the what is it, generating function of an. However, it is in this form, and we need to find the polynomial form, so we can get the coefficient and we can extract the sequence from the coefficient. Okay, remember that the standard form will be this one, right? 1 over 1 minus x, because this is a geometric series with ratio of x, And if we can get this form, we can get the series form. And how to make that in that form? We use partial fraction. Okay, so we'll have fx is equal to 6, and maybe we can factorize this one, and you can check that that will be 1 minus 2x and then multiplied by 1 minus 3x. Okay, we can break it up to this one, a over 1 minus 2x plus b over 1 minus 3x. Or if we multiply this together, so we'll have a 1 minus 3x, I mean not multiply, we add up them, and b have 1 minus 2x, and this will be 1 minus 2x, 1 minus 3x. Okay, now forget about this first. So remember that this has to be the same as this one, right? So I will have a 1 minus 3x plus b 1 minus 2x. It should be equal to 6. Okay. Okay, now to find out a, I think we can just set the x into 1/2, right? If we check x to 1/2, so I'll have a 1 minus 3 multiplied by 1/2, that will be 3 over 2, and then plus b 1 minus 1, and that should equal to 6. Yeah, and then this one will be minus 1/2 of a, that equal of 6, and from here I will have a is equal to minus 5. Okay, now let's set another x to find out what b is. So I will set the x is equal to 1 over 3 or 1/3. Why? Because this term will cancel out, right? So I will have a 1 minus 1 and then plus b, and I will have 1 minus 2 over 3, that should equal to 6, and then this term will cancel out, and I will have b multiplied by 1 over 3 is equal to 6, and we got that b is equal to 18. Okay, so now we got our generating function in this standard form. So I will have fx is equal to this one, so I will have minus 12 divided by 1 minus 2x plus 18 divided by 1 minus 3x. Okay, we can rewrite this one, the generating function. So I'll have fx is equal to minus 12 multiplied by 1 over 1 minus 2x, and then plus 18, and this one I will have 1 over 1 minus 3x, right? Okay, we can change this into its polynomial form because this is a geometric series with a ratio of 2x. So I will have fx is equal to minus 12, and then if I wrote this as polynomial, I will have 1 plus 2x, and the ratio is 2x, so I will have plus 4x squared, and then plus 8x to the third power, and then what is it, 16 x to the 4th power, and so on. Okay, and then plus 18, and this one will be similar as this one but with the ratio of 3x. So this is a geometric series with ratio of 3x. I mean infinite geometric series with ratio of 3x. So I'll have 1 plus 3x plus 6x squared plus not 6, that's 9 because the ratio of 3x, right? So that's 9, not 6. Yeah, 9, and then 27 x to the 3rd power, and then plus 81 x to the 4th power. Okay, we know exactly what sequence is this because this is 1, 2, 4, 8, 16, so that is 2 to the power of n. So I'll have a n that will be minus 12, and this is the generating series of 2 to the n, right? And then this one, 1, 3, 9, 27, 81, that will be 3 to the n. So I will have 18 multiplied by 3 to the n, right? Or maybe we can just write the positive one first. So I'll have an is equal to 18 multiplied by 3 to the n minus 12 multiplied by 2 to the n. And this is the final result. So this is the sequence, or this is the closed form of this recursive function. So hopefully I did not make any mistakes in the calculation. Thank you for watching and bye bye.